Hey everybody, it's us today. So, well, welcome to the talk. Welcome to. I hope you guys are enjoying the Percona live. You're having a great time here. Good talks, good conversation on the surroundings, right? It's always good to see new people. Thank you. Especially. Uh, especially coming back after the pandemic crisis, right? So seeing people back again, the conference there start slowly, but we're getting back. So it's really good to be here. So today we're gonna talk about disasters, recovery, database, and backups. So I'm Charly Batista. I'm currently the Postgres stack lead at Percona. I've been working with database for quite a few days now, so it's been 20 years. I'm now located in Brazil, in the South America, but I used to live in China. And we're planning to go back because my wife is Chinese, so it's hard to keep the people apart from the family, right? So, and we're planning to go back probably next year or so. And we can find myself on LinkedIn here, information if you want to drop a message, questions, anything that we can help. So just drop a message there. I'll try to help the way we can. So our agenda today we're going to talk about disaster, right? So basically we're going to discuss about backups, what are backups, what are not backups. So what is this point-in-time recovery, how this is important, how it's not important, what are the things they do. And by the end of the presentation, I'm going to give you an introduction about PG backups. So the main message that I want to give you guys today is really about backups and how backups are done in Postgres. Right? And how we can keep our database safe, right? So when we talk about disaster recovery, we have many expressions, many words, many things. And a lot of people, they do not really understand, or there are a lot of misconceptions when it comes to disaster and recovery, right? So what is disaster recovery? What is backup? What are those things? So I'm going to start with backups. Backups is just a method or process of creating a copy of the database. And when we say creating a copy of the database, it's creating a consistent copy of the database. Because it's pretty easy to go to the database and do a sync or a CP, or depending on your operational system, you can get a copy of the database, right? But if the copy is not consistent, it's just useless. If you copy the database and if you cannot spin up the database using that copy, it's a waste of time and money. So a key point for backups is consistency. Backups need to be reliable and consistent, right? Backups, they can be full, they can be incremental and differential backups. Well, full backup, as the name implies, copies everything, right? It's a full, you're going to copy everything that you have in a database, and there is nothing much we can do. But what are the difference from incremental and differential backups? Do you guys know? What is the difference? What is incremental? What's a differential backup? So incremental is based on the previous backup, but doesn't matter what happens. And what is the differential one? Good question, right? As we call them, yeah, they might be different things, right? So yeah, you're correct. The incremental backups are always based on the previous one. We can have a chain. Let me try to do something here. Let me see. Where is my mouse? So that's why we're trying to understand now. So see here, I have incremental backup. This incremental backup is based on my previous backup. It doesn't matter what type of the previous backup is. Can be a full backup in my example here, or can be another incremental backup. So the incremental backup is always based on the previous backup. A differential backup, for the other hand, is always based on the full backup, the last full backup. So let's say we do a full backup every Sunday, right? And we do smaller backups during the weeks. So if we do incremental backups, the backup on Monday will check the previous ones as the Sunday, so the full backup, and check what has been changed from the backup on Sunday to Monday. The backup on Tuesday, gonna check the backup on Monday. So the previous backup now is an incremental one. So what has been changed from Monday to Tuesday, gonna be the new incremental one, and so on and so forth. So the backup on Saturday will check with the previous one was on Friday. So incremental backups, they're always smaller because we always have that smaller period in time that we need to check. But then we have a chain. So if I want to recover the backup up to Saturday, in this example, I need to recover the full backup, the incremental backup on Monday, Tuesday, Wednesday, Thursday, Friday, and then Saturday, right? What happens if my backup on Wednesday is corrupted? I broke the chain. I cannot recover the backup on Saturday because the chain is broken. That's one problem with incremental backups. Because as they depends on always the previous one, we really have a chain. If the chain breaks in the middle, we can only recover up to that point when we have that corruption on the backup. A differential backup, for the other hand, always based on the full backup. So I took a full backup on Sunday. Well, on Monday, going to be the same. Going to check with the full backup on Sunday. On Wednesday, going to check with the full backup on Sunday. On Friday, on Saturday, they always check with the full backup. So as we can see, the differential backups, they start increasing day by day. So the backup on Monday going to be probably the same size as the incremental on Monday. On Tuesday, a bit larger. On Wednesday, more. On Friday and Saturday, going to be a lot larger, depends on the amount of data that we have, than backup on Monday. But then, what happens if the backup on Wednesday crashes just like the incremental one? Nothing happens. If I just need the backup from Saturday, I just recover from Saturday because it has all the changes that happen from the full backup up to the Saturday, right? The only problem is, well, if I need to recover exactly on that day that we have a crash, well, if that day the backup is inconsistent, so then I have a problem. But I don't have a chain anymore. So every day is a new, is compared with the full backup. That's the difference from incremental and differential backups, right? So depends on the circumstance and the situation in your workload. Going to be better to have an incremental or a differential backup. That's no formula to tell you which one is better. So if you have space and you want to keep all the differential ones, that's fine. But also the time to take the differential backups is larger than the time to take the incremental because now you need to save a lot more stuff, more things. But for the other hand, recovery is faster because incremental you need to recover all the chain. The differential will only recover the full backup and the one you need. So there are pros and cons with both of them. They all have drawbacks and good points. Well, backups can always be categorized as physical and logical backups. In Postgres, we don't really consider them as a backups. So they are plain dumps. We usually don't call them backups, just copy of the data. But some other databases, they only have logical backups and they call it backups. Well, it is what it is, right? So now what is high availability? high availability is the property or the ability to stay always available, stay always on, right? So, and the concept of high availability also highly depends on the infrastructure you have and the problem you want to solve. For example, can I have high availability with only one server? How do you guys think? Is it possible? It's complicated, right? Because if the server crashes, well, it's going to be offline. It won't be available. So I cannot have high availability with only one server. Well, what with two servers? Well, if I have two servers, a primary and a replica, if the primary crashes, we can get the replica and to be available. So yeah, it's possible to have some level of high availability with a primary and a replica. So the availability, the high availability is the property or the ability to stay always on. But remember, always on also depends. If you have your primary database and it's been overloaded and your application is not able to do a select, even though the database is on, it's not available from the application point of view. So staying on does not necessarily mean to be available. And this is when it gets tricky. But for what matters for us here, stay on and be able to answer the query, going to be availability. So there are many ways to keep the availability, to keep with high availability. And on the database world, we usually work with copies of the database. Can be replicas, can be other primary instances, or can be a whole cluster. And then we have levels of availability. So the example that I gave, when we have two databases, one crashes, we keep availability with other database. So we are keeping the availability inside of the same data center, right? What happens if we lose connectivity to that data center? And it's not that it sometimes seems something that never happens, but Lufthansa, a few months ago, they stayed for a whole day, no servicing, no flights, because there was a construction in Frankfurt, and someone just broke the cables from the Lufthansa data center. And they had multiple cables. The problem is because all of the cables are going through in the same pipe. And they lost the whole data center. So no availability at all, right? So to keep high availability, we can work with clustering, we can work with network balance, we can work in geographic redundancy. If Lufthansa had another data center in a different area to answer the queries for that, it wouldn't be a problem, that would be available. So different problems, they need different addresses to different solutions, right? And this is when we come to high availability. Okay, but what does high availability have to do with disaster and recovery? So when we talk about availability, there are many ways that things can go wrong, right? And the main example that we give is the database crashing. So if we have replicas around the globe and the primary crashes, it's easy. You just spin up, promote another replica as a primary, so that's pretty easy to solve the problem. We solved the disaster. But what happens if we have a bug in the application, and that bug do a delete for a very important table? Or rather, do a drop table, or a drop database, or if we have a rack attack here, a hack attack, and someone just gets our database. The database is still running, still on, but we had a different type of disaster. In these circumstances, having 1,000 replicas will not solve the problem, because the same problem will be replicated. Now instead of have one problem, we have problem in 1,000 replicas, right? So this is a type of disaster that replication does not solve the problem. And that comes to a point. Replication is not the replacement of backups. If you use your replicas as a backups, they may bite you back. That can happen. So if you have a disaster in the sense that it's a logical problem, your application won't be able to keep up. I've seen a lot of companies, they using delayed replication. Oh, no, we have 1 hour delayed replication. If someone drops the table here, we just stop replication and then, okay, so you stay looking at your database 24 hours a day. I don't know, we can increase for 2 hours delayed replication. You can have a near delayed replication if you never realize that something happened to your database. The day that you need that data, it won't be there. So replication is not a replacement for backups. Only backups are replacement for backups. So the next full backups will replace the previous one. And that's it. And comes, okay. Now that we know that they are not replacement, how can we do those backups? And as I mentioned, if we have a drop table, in this example here, we have an application work. We do backups every day, right? We do backups every day at midnight. So if something happens, the disaster can just recover the backup. What happens if we have a crash 7 in the morning? Someone did a drop database 7 in the morning. Or the database crashed and we need to recover the database. So we can recover from the full backup. Or from the incremental backups, or whatever backups we're taking here. But what can we do from the data from midnight to 7 in the morning? Cry, right? Let's check the logs. Does the application have logs? Can we replay those logs from the application? Does the database have logs? Can you replay the logs? Logs are important. And Postgres has a really good one we're going to see that they call wall logs and going to help us in these circumstances. So in this case here, what we need to do was they call a point-in-time recovery. So we need to have objectives for how much data we want to lose. Or how much, not want, because nobody wants to lose data, right? How much data can we afford to lose? Some applications, they can afford to lose 4 hours data. For example, if Facebook loses 1 million posts, oh, so bad, right? Yeah. Life happens. Can you post again? It's not a deal. But if your bank call you in the middle of the night, say, sorry, man, we had a database problem here and we just lost all your transactions for yesterday. That might be just one transaction, you know. Your paywall went there that day and they just lost for the month. So the amount of data we can lose and the type of data is very important. It's not because it's 1 terabyte of data or 1 byte of data. It's usually what type of data that matters. So if your application can afford to have 4 hours, to lose 4 hours of data, well, you are in a good point. We can work, and maybe that backup that was at midnight and something happens, maybe you can do backups every 4 hours, right? You can afford to lose 4 hours of data. But what if you can't? If you cannot lose any data or minimal of data. This is when the point-in-time recovery comes in place. This is when the Postgres log comes in place, but not all the logs. The WAL file logs, the archiving logs. Those logs that are used mainly for replication, we can use them to recover data up to a certain point, up to when we want them to be recovered, right? So as I mentioned, if we can afford 4 hours of data, lose 4 hours of data, we can have a huge backup, a full backup, and then every 4 hours we do incremental backups. That's okay. It's not practical, but that solves the problem, right? If we cannot, we need to go for a point-in-time recovery. And what is a point-in-time recovery? So as the mention names, is a type of recovery that you can tell to the database, I want to go back at this point exactly in this moment in time and recover my data up to that point. That point can be now, or that point can be 1 hour ago or 1 day ago. For example, the example of the drop database. So if you have a drop database, a mistake of a DBA or application problem, and we find the timing that the drop database happened, we can recover the full backup and tell the database, look, I want you to recover just before, exactly before this transaction. When you come to this transaction, just stop, because I'll copy all that data from that table, and then we do a manual process, whatever we need to do, but we are able to get the data from that table. This is a point-in-time recovery. So we recover everything that we need to recover at that point. Can be a time, can be a transaction ID. So just tell the database when you want the database to stop. Right? Yeah, but how does this really work? This is what we're trying to see now. Let's crash our database. Right? It's always fun to do some crashes. Where's my... Okay. So what I did to make things faster, I have my nice script here that's going to help me. So before we start proceeding, okay, we need to do some checks on the database. The database needs to have some configuration set. For example, the archiving mode needs to be enabled, needs to be on. We also need to have archive command. Do you guys know what's archiving in Postgres? What does that do? I've seen a lot of really bad tutorials on the internet talking about those topics. You know what is archiving? Sorry, can you say that again? Keeping the right. Yeah, but yeah, that's basically it. Archiving is just copying the WAL files, the write-ahead logs, to a different location, right? That's archiving. As the name implies, just copying the files. We just copy that files to different locations, right? And why do we do that? Sorry? Yeah, we can use them in the future, but like, do we need to copy them for a different location? Can we leave them there? We can do whatever we want to do. That's the thing, right? We can leave them there, but shall we? Well, there are two problems on leaving the archive in there. Well, the first problem is that folder going to increase exponentially, right? So we're always creating WAL files. Every time that we have a transaction, you're going to write to the WAL files, and so it grows, and then your database is going to just stop or crash because that archive, that folder that we have the WAL files doesn't have physical space anymore. It's a common problem. And there's a configuration on Postgres that you can tell to the Postgres to do the cleanup of those WAL files. It can be based on space, it can be based on many different and other different things. So if we ideally should tell the Postgres to start cleaning the WAL files. And that's why we archive, because we want to copy them before Postgres remove them. And those archiving, they're usually used for replication, remember? So if you have a problem in your replica, for example, I need to stop the replica because I'm updating the OS. Updating the OS and then you stop and something happens, you're planning to stop for 1 hour and then you stop it for the whole day. And when you put that replica back, those WAL files probably will not be there anymore because they've been reclaimed by Postgres. In that case, because you don't have your WAL files, the replica won't be able to replicate again from the database. Those are the binary files from Postgres. The replica will stop in complaining that I cannot find this WAL file, so I cannot do anything. And that's it. The replication will not proceed. If you archive that file, if you copy to another place that replica also has access to that place, the replica will go to the primary and ask for that WAL file. The primary say, I don't have them. And okay, then it will go to that alternative place that we call recovery place, and we also have a recovery command on Postgres, and you try to copy that file. The Postgres does it automatically. And copy that files, and when done, we start going back and replicating from the primary. This is one of the main purposes of having archive, to keep always a replication always working. Doesn't matter if we remove the files from the primary. The replication will always be able to replicate. If you don't have that one, we need to rebuild the replication from a full backup. Well, if you have a 100 gigabytes database, that's fine. But you start having like 15, 20 terabytes database, that might be a problem. And that's why archives are so important. So yeah, we enable them, and the other reason is for our backups, right? So we need archive to do the point-in-time recovery. How the point-in-time recovery works is Postgres will get the full backup, and then we tell to the Postgres, look, man, I want to recover up to this point. In my example here, this is the recovery target. I want you to stop at this point. And the Postgres will use the archives, the WAL files that we have in the restore command to replay everything. It works like a replica. It starts replaying that data and going to stop here. And this is the point in time that we're going to stop our recovery. So the WAL level needs to be replica. And I usually like to change the log destination. So let me double check here in my configuration file. Oops, not this one. So I want to go for data, DB, PGSQL, 15. So I check my configuration file. So I do have archive mode on. I do have archive command. I'm doing an rsync, so basically copy. There are fancier ways to do, and we can use pgbackRest. We'll see later that. So it's a fancier way to do to archive them. In my case, I'm just copying, doing rsync, copying from the Postgres folder to this folder. Okay, let's see what we have in this folder. Come on, one more. Okay. So I have a lot of archives here, and I have some backups. I already did some backups here on this node. Those are manual backups, and it's been archived, so good. I have a history of archives here, all good. My database is working fine, and their archiving seems to be working fine, right? So my configuration is done. What I need to do now, before I do anything, is to do a full backup, right? I'm creating a full backup in this folder here. I'm using the pg-based backup. It's a tool that comes with Postgres. I'm telling him to connect to this address. It's my local host. Use the user Charly. I want to see the progress, and I want to save my full backup in this folder here. So, and this is what we're going to do. As we can see here, it finished. Well, my database is pretty small. We didn't even have chance to see the progress here because it's too fast. But, well, it finished. If I check my archive, let's check the archive. Remember that the last one that I had for today, 844, not 84, well, 1009 was this archive here. And I should have another backup. So this is the backup that I just created, 1121. So I do have the backups here. So, well, this is not the backup itself. This is just a mark that Postgres is creating, saying that this did a full backup at this point, at this position, at this WAL file, it did a full backup. The full backup itself is stored in this folder here. Oops. Oh, interesting. I can move using this here. So the full backup itself is stored in this folder here. And it's a physical backup. So if I copy here and check what we have inside, we see that we have all the database files. It's a full backup. And it's a consistent backup. So I can just start my database pointing to this folder here. My database will start without problems. It's a consistent copy of my database. Right? You can. You can. It doesn't do any lock. It's an online backup. So you can keep writing here. There's no problem. So while you're doing the full backup, it doesn't stop your database. It doesn't put any lock. The PG-based backup, it doesn't do any lock to the database. What it does, as I mentioned, it creates a mark saying that, okay, I'm starting a backup. And it do a checkpoint there on the database. It's forced, like we can force a database checkpoint. The backups only starts after checkpoint. So, and that checkpoint, it put a mark saying here, it's a text file. Let's say what we have here, right? At this position, oops, everything inside of the database is consistent. At this position, this WAL file, inside of this very position, the database is consistent. You can copy physically, and the database will do the up to this point and start everything. Yeah, the PG-based backup does. We can do it manually. Actually, we can connect to the database, run the start backup command, and give it a label. And after that start backup, we're gonna do a checkpoint, and we can do a rsync. And after rsync, we do a PG stop backup. So Postgres, when we start Postgres, point to that folder, it will see that mark. They start backup, we see the mark for the end backup, and go to the WAL files and do a redo and reload the WAL files up to the last checkpoint. It makes the backup consistent. We can do a physical, literally physical copy, rsync, CPU, whatever we want to do. So PG-based backup automates this process. This is basically what it does, right? So at this point in time, we do have a full backup. This is a full backup. Everything is consistent. I have this table here. Let me see if how many rows I have in this table. Well, actually, that's not what I wanted to do. I want to do is select, not now, the count. So, see, I have 1,000 rows here in this table. My full backup has 1,000 rows, right? I can keep writing things. For example, let's insert more 1,000 rows. So if I do a select here, now I have 2,000 rows. So if I recover something happens now, I have a crash and I recover my full backup, I will miss those 2,000 rows. Because those 2,000 rows, they've been inserted after my full backup. They are not in my full backup now. So that's all cool. I will force just here to have a new wall files to make sure our database is always keep with things. What happens? Okay, let me do a select now. So at this point in time, remember we have 2,000 rows. The full backup doesn't have, but in our database we have at this moment in time 2,000 rows. What happens if I go here and delete? So if I do a select, where is my select count? I just forced the wall file to be written to the file. So we are always consistent because we're not writing too much. It takes some time for Postgres. So now we have 0 rows, right? But we know that at this moment here, that was just before the delete, we had 2,000 rows. If I recover my full backup now, we only see 1,000. The full backup will not solve the problem. Now we need a point-in-time recovery. So to do a point-in-time recovery, we need to do 2 things. We need to tell the database where we want to start and stop. So I will copy here. That's where I want the database to stop, right? Because at this point in time here, I know that I have those rows. I just tell here the recovery target time. And I also need to tell the database where to find the wall files, my archiving. So I'll copy those 2 information and I save inside of the Postgres configuration file. So I created my backup. Remember, I created my backup on the folder data, db, pgsql, backup 15. So that's the folder I created my backup. We can double check here. Yeah. Data, db, backup 15. So inside of this folder, I have the Postgres config file. So this is the config file, exactly the same that came from my primary. When we do a full backup, it copies everything. It's a physical copy of that we have on the primary, right? So I'm gonna change the port here because I want to start this instance, and just because I have my primary running on the port 5432. I don't want any collision. Well, I'm gonna put in 5435, just to make sure. And I can put that configuration here. That configuration that I copy, I can put here, but I usually like to put on postgres.auto.conf because it's a configuration that we don't need to be persistent. Well, this also came from my primary, right? I have auto vacuum disabled on my primary. Amazing practice. Never ever do that in production. I did it because my previous talk, but never do that in production. Actually, I'm going to remove, so I don't want this bad example to appear here. So I have the restore command, and I have the recovery target time. I'm almost there. Now I need to tell the Postgres that it's in recovery mode. To tell the Postgres that in recovery mode on the versions 13, 14, 15, we need to create a file named recovery.signal. The file should be empty, doesn't need to be anything, we just need the file to exist there. I just do the touch, so I create them. And I can try to start my database. So I'm gonna do a pgctl start, pg_ctl. So, and point to the, not you, but the backup 15 folder. That's the folder of my database. Well, but before I do that, I want to clean up my log files, because I want to check if something goes wrong, something goes bad, and it usually goes during my presentations. I want to check the log files. Okay. Yeah, it did. It could not start the database, so something went bad, as I mentioned. Not surprises me. I still don't know why I do live presentations. But here, probably, what happened is, let's check. Oh, it could not find this file here. Remember that I mentioned that we are not writing too much and the archiving is not copied. Probably that file is not copied over. So let me try to cheat the database here and do a switch wall and hope for the best. I'm gonna clean up again because I want clean log files. Again, still the file is not there. Oh yeah, we have a problem here. See that the timelines here, it's complaining that the database, it changed the timeline. I restarted in my database a few of times here and I messed it up with my timeline. And those files are not there. So if the file is not there, we should hope it's 15. The file doesn't exist anymore. And this is a good example when we do not fully archive all the files. In this example, I cannot do a point-in-time recovery because I do not have all the WAL files. This is what can happen as well when we have incremental backups and the backup just breaks in the chain in between. So it's...
I thought I saw in the archive before you did switch wall that you had timeline 2 files.
Yes.
When you did switch wall, it was creating timeline 1. So were the files just there from some previous example, maybe?
Yeah, that's a good observation. We are data, DB, PGSQL, archive. That's a very good observation, right? The backup was created on timeline number 1. Can we fix this? And actually, look, the WAL file is here, the one that is complaining. Well, the database seems to be still on timeline number 1, right? So what happens if we try to cheat the database? No, these will not work. Let me do one thing here. Let me do the switch wall. Yeah, it's still on timeline number 1. I should have... This is the last one. 1A, 1B, 0A. Yep. That was a good observation. So one thing that we can try to do here, and it may or may not work, but because we are desperate to recover the data, sometimes we need desperate solutions, right? We can go to this folder here. Let me go to just to this folder. Okay. Didn't. It's data, PGDB, PGSQL, backup 15, log, R6. Ah. This is a low-worst problem. No, it's not complaining about the 17 only. It has stored from the 17. The problem is saying that there is a timeline that's number 2, but the timeline number 2 didn't fork from the previous timeline. So we have 2 different branches. And this is a problem on my primary. I have a problem on my primary here. It's going to be a bit tricky to solve. The easiest way to do here, to solve the problem, just for us to see the point in time we're working, would be stop my database. I do know what happened here. I was playing with Patroni in one of the sessions, and I did a manual switch over here to show exactly the problem, because Patroni has one thing they call standby cluster. That even though the name is standby cluster, it's not managed by Patroni. So you can have split brain situations. So depending how we do, we can, from the same timeline, we can branch from different, because we start every time that you do a promotion on the primary, it creates a new timeline, right? So Postgres starts on the timeline number 1 and uses that timeline to control the flows of data that go from the master to the primary. So every time that you promote one replica, it creates a new timeline. That new master will be on the timeline number 2 now.
Is the root, I'm sorry, the root cause because you're rsyncing to the
Same all files, exactly. Yeah, yes. That's. I already messed because he written the WAL file.
But the archive, or the timeline 2 file that's in the archive?
That's a good point. The files are still on the primary. And that's a very good point we can do. So I can do an async. We can try that one. From data db pg 15 pg wall star to data db pgs archive. Yep. And now I need to do another change. I am on backup, because if I do not, I messed with my backup. Let's try, it probably has messed with my backup data, but it has a chance to work. Then PostgreSQL.conf. What we want to do is archive off. And this mess it up with them. Do I have my recovery.signal? Yes. No. Let's log. It is 1.4. Yep. The problem is already messed up with this backup. So, as I mentioned, the easiest way now is to just remove this backup. So, remove the backup. We do again the process. So, let me just insert here. Oops. We have 1,000 rows. Good. I do a new backup. So we have a full backup. Now I can insert again. We have 2,000 rows. At this point in time, we do have 2,000 rows. If we do delete now, I'm just archiving my files, so we don't have anything anymore. Yep, and this is the point in time. Let's be careful not to mess up with the archive anymore. Well, where is cd backup? So we disable this one. We disable this one. We don't want to keep archiving to the same place. I'll change the port. 35. Oops, I have an I here. The auto.conf. Let me remove my vacuum. The target. Recover.signal. Clean up the logs. We start and hope for the best. Yay, the database is started. So if we check the logs, we see here that recovered, right? Recover and stop before the transaction at this time. Exactly at this time. If we connect to the database on the port 5435 and do a select count star from theap, we have our data back. We just did a manual point-in-time recovery. So you see, we can have a lot of difficulties and problems here, right? For example, keeping right to the archiving file. And so that we can compromise the things when we do not have a good procedure. We can automate this process using PG backrest. So for example, here I have a patronic cluster when I have a primary and a replica. So I have a backup server here. It's a totally different server. When I do my full backups and everything, right? And I can do, for example, a full backup now. Let's do a full backup. That's it. It automated, it did the full backup, and now we have the full backup.
We are running out of time. We're about 6 minutes over.
Okay. Just show how we can recover the backup from the replica. It's pretty, yep, it's pretty straightforward. That's the command we need to run. You don't need to change files and anything. You just tell that you want to recover the backup, and this is the target that you want to restore. And that's it. Thanks, everybody.